facing the right direction. So, Patrick, merci beaucoup pour m'avoir sur le stream. Je suis désolé, il y a beaucoup de temps que je pratiquais le français et je parle un petit peu, mais je vous remercie beaucoup. And that's all I know. So thank you so much for having me. I really enjoy being able to talk about linkerd and service mesh. And so with that, I hope we can just jump right in. Today I'm going to be talking about service mesh basics with linkerd. Can you see my screen all right? Or I need to share the screen, right? There we go. Okay, that makes sense. Let's see. Entire screen. And we want this one. Okay. Okay, we're good. Great. Okay, so what I'm going to talk to you about today is using linkerd and the reasons why we want to use a service mesh. So there are a lot of reasons for understanding. Let me take a step back. Sometimes folks get confused about why would I want a service mesh? Why do I need it? My Kubernetes installation is already extremely complex, or my distributed application is extremely complex. And so oftentimes I'm talking with folks just to demystify or help them to clarify some of the reasons why you would want to use a service mesh. So we'll jump straight into that. Brief introduction. My name is Charles Pretzer. These are all of my contact information. You can you can tweet me on at charpretz. I'm happy to chat with you about the history of the work that I've done, but you can email me directly. So if you have any questions, even after this presentation, we can go and we can talk about those as well. So today, we have about 30 minutes together. I hope to discuss just, again, overview of the service mesh. I'll show you how we install linkerd, and you're in luck because we just released linkerd 2.7.1 yesterday. So we'll get to see that being installed. I'll talk briefly about the service mesh interface, or SMI as it's called, and then we'll leave about 5 or 10 minutes for questions or discussion. So let's jump right in. Service mesh overview. Again, the question that I get all the time is, why do I need a service mesh? What does it offer me? And that's, if you take anything away from this presentation today, that's what I hope that you understand is there are valid reasons for using a service mesh. You may not need one today. The way that I have seen companies evolve and grow, especially as they go through this digital transformation, we find that they get to a point where they have their application is expansive enough that they really need to get a hold on what all of their services are doing, all the communication that's happening between them. And so this is the main reason why we say that even if you don't need a service mesh now, I think you'll need one. You will definitely have the conversation. You'll be in a meeting. Somebody will send you a calendar invite that says, should we have a service mesh? So you can I hope you can take the information that I'm giving you today, or revisit this video later and take it to that meeting and say, these are reasons why I think we should use a service mesh. So let's talk about what is a service mesh. Here we have just a very basic distributed application. You've got 3 services. This diagram in particular is one that you see almost all the time at any given conference before anybody talks about any cloud native software. 3 services, 3 seems to be the magic number, and some arrows connecting them all together. What the reality of a distributed application looks like is multiple services. You've got your traffic coming in. The services are communicating with each other, and not necessarily in a circular or a linear way. You may have some services that are making calls to external APIs, and you may have some services that are writing to persistent data stores, whether that's a NoSQL database or even a relational database. or a cloud database. The reality is that we have complexity, and the more distributed our applications become, the more complexity there is. And I've seen this through my career. I started working on monolithic J2EE applications, specifically e-commerce applications. And so we would have to do things like maintain catalogs, product catalogs, and user databases. And this, if you've ever worked with a J2EE application, then you know that rolling one of those out requires this massive jar file, and you have, maybe a week's worth of performance testing and QA testing before all those things go out. So this is now the way things are going in the future with microservice architectures, or service-oriented architectures, where we're seeing these distributed applications. And so this is where service mesh comes into play, because as we have multiple instances of multiple services, to be able to wrap our minds around all of those, how each one is performing, or what may be going wrong in a particular place, or for a specific service, it requires a lot more attention. And so if we can automate some of this, that becomes very helpful. And I think that's where the tie-in between service mesh and DevOps comes into play. The stream is about DevOps insights. And so the service mesh, I hope, will give you insights into the next steps that you can take. So let's take a look at our application. We see that it's running here, but all of a sudden we get, let's say there's a spike in user traffic, or our database queries for some reason are just taking too long. All of a sudden you have a downstream service which is failing or impacting your upstream services. What's the mean time to detection? We don't know. One of the goals of a service mesh is to try to reduce not only mean time to detection, but mean time to resolution. Another thing that could happen is this external API goes down. If that happens, then you're sending your traffic, and your service Y over here is making calls. Maybe you've reached your quota for this external API, or it's just gone down. For some reason, it's become unavailable. And again, that is a downstream service that is going to impact upstream services. This is another thing, another metric that the service mesh can help you discover. And then my favorite one is if we end up, this is an escargot, of course, and as you know, escargots are very slow. I may have been guilty of this once or twice, where I've written some code and deployed it, and all of a sudden the application slows down a little bit. And so I'm sure this never happens to anybody else, but for me, it's very helpful if I can understand the latencies of each service and look at the difference, the delta between version 1 of a service and version 2 of a service. And if version 2 is slower, then I know that there's an issue. Or maybe version 2 is faster, and that's the ideal. Well, ideal would be version 2 is the same, at least the same or better, performs better. So these are all different things that can happen in our distributed application. My favorite, though, is when one or more of these things happens at any given time. And so this is when pagers start going off. People get called, as they say in the DevOps world, at 2 in the morning or 3 in the morning. It's never 1 in the morning. It's always 2 or 3. And so that's, this is probably every SRE's nightmare, every DevOps practitioner's nightmare, is when multiple things go wrong at any given time. So the service mesh seeks to address that in a couple of different ways. Let's look at how the architecture of a service mesh, and this is linkerd agnostic right now. We're not talking about any specific service mesh. What we're talking about is the interaction, how a service mesh works into this distributed architecture. So there are 2 planes. You've got your data plane and your control plane. Now the data plane can scale as large or as small as you want it to. That's funny. The data plane can scale as large or as small as you want it to. The way that it scales is as you have more services. These proxies are injected as using a sidecar pattern. So as you have multiple instances of any given service, a proxy gets injected into the sidecar, or sorry, into the pod. Specifically in a Kubernetes architecture, linkerd injects a Rust proxy into a pod. And I want to be pretty clear about that. Is oftentimes folks think that, well, I've had a few people ask me if linkerd uses Envoy, and that is not, it does not. Linkerd has its own proxy that's written in Rust. The repository is open sourced on github.com/linkerd, and I have all these links in the slides so you can see them later. But the point is, the linkerd team actively selected Rust as the language of choice for memory safety reasons. C++ is known to have some memory issues, and also because it is a developing ecosystem. So the linkerd team was very interested in Rust, or is very interested in Rust, because we can help grow that ecosystem out. So again, the data plane for linkerd is our sidecar containers written in Rust that are injected into your pods. And I'll show you one of these when we go through installing linkerd. The other part of the service mesh is the control plane. And the control plane is more of a finite set. With linkerd, you can install, a finite set of workloads. With linkerd, you can install the control plane as in a developer mode, which is that's what I'll show you today. You'll have one instance of each of the services for linkerd, or the linkerd control plane. Or you can install in an HA mode, which deploys 3 replicas of each of the components. And that'll make more sense once we take a look at the actual workloads that are running. So that's the basics of the service mesh. You've got your control plane, which is generally fixed size, and your proxies, which for us, they're lightweight, highly performant proxies. They use low memory, and they also require low, resource requests, CPU and memory resource requests are very, very low for these proxies. So now if we look specifically at linkerd, we come to some of the main concepts of the service mesh and how linkerd implements those. So the 4 concepts that we talk about are observability, security, reliability, and traffic management. With the initial version of linkerd, and everything that I'm going to show you today is linkerd 2. Linkerd 1 came out in 2014. It was a JVM-based executable. And so all of the concepts that we learned from linkerd 1, we brought over to linkerd 2 and wrote them in Go and Rust. So the main reason that linkerd exists, that a service mesh exists, is for observability. What I showed you before in that complex diagram, when with the snail, and when things slow down, or when that external API fails, that in order to understand where the failure is happening, to reduce the mean time to detection, we want to understand the success and error rates of each of those services. We want to understand the latencies, the golden metrics. So that's the P50, P90, P95, P99 latencies. And we can also then dig into things with by collecting those metrics, we can export those to something like Jaeger or Zipkin, which can then provide us with distributed tracing information. And that's more of an advanced topic. I will be doing a Twitch stream at some point where I talk about distributed tracing with linkerd, so that'll be fun. The next thing that, one of the core concepts that we talk about for service mesh is security. And so linkerd enables automatic mutual TLS by default. So what that means is, as soon as that pod or the proxy container is injected into the pod, Linkerd is going to go and get a certificate from one of the control plane components, and that certificate will then be used for communication with other workloads, other proxies within the service mesh. So that means that your traffic is now encrypted. Your east-west traffic is now encrypted. So even stuff that's behind the firewall is encrypted without adding any code, any additional libraries or code to your actual business logic. So we're adding this layer. Your business logic can handle just regular HTTP traffic, but Linkerd will encrypt that traffic in between each of the services. So if you imagine you've got multiple instances of multiple services running on a single cluster, that cross-node communication is going to be encrypted, which is important for some folks like banks and telecoms need this encryption because of regulation. I imagine in Europe and France specifically, you have a lot of GDPR concerns. You probably have a lot of meetings about GDPR. So this helps you meet those compliance rules, this automatic encryption. Other companies, other industries require this by just by internal requirements where they want their own traffic to be encrypted internally, especially if you're building out a platform where you have multiple tenants. So in a multi-tenant cluster, you want that traffic to be encrypted to protect everybody from themselves or from each other. Next, we have reliability is the next concept, which is load balancing, retries, timeouts. This ensures that the application continues to perform well. The observability piece helps you to understand how it's performing. The reliability piece lets you, there are features built in that say, this is how you should perform. It gives you the tuning aspects for the metrics that you get from the observability piece. And finally, we have traffic management. Specifically in Linkerd, that means traffic splitting, and this is done through the service mesh interface spec, and we'll talk about that briefly. So I'll pop over to the chat box real quick to see if we have any questions, and it looks like we're okay for now. So we'll keep moving on. Let's see. We'll do a quick installation of Linkerd. This is my favorite part of the demo because it's really fast and easy to get started. So right now I have a cluster. I'm running Kind locally. So Kind is Kubernetes and Docker. I find it very easy to use. If you've used, for me, it's much more easy than Minikube, and it's comparable to K3s. So that's what I use locally for my development and working with Kubernetes when I don't need a full cluster. So we see I have, if I'm listing all the pods in the cluster, and all I have is kube system. So this is fresh. Everything was started about 30 minutes ago, right before we started this. So I've already got Linkerd in my path. The instructions for installing Linkerd are right here, are on the Linkerd website, linkerd.io/2/getting started. So I've already got the CLI installed. I did that yesterday because we did that new release of Linkerd 2.7.1. So I've already done steps up to here. We're going to start with step 2, which says, let's run Linkerd. Actually, let's first do Linkerd version. And we can see that I'm running stable 2.7.1. This should look very similar to kube control version, which shows you your client version and your server version. And you can see that I don't have Linkerd installed on my server. So we'll go Linkerd check -- pre, and this goes through, it communicates with the Kubernetes API server and makes sure that it has all of the permissions that it needs to install. There are things like creating IP tables that are required that require certain permissions. There's also a CNI plugin, which allows you to make a more strict environment if you're using RBAC. That's out of the scope for this particular talk, but linkerd does support CNI, which is cool. So everything is green, which is great. We know we can move on. So I'm going to do linkerd install. And what that's going to do is just dump a bunch of YAML. This is all of the, actually, we'll do less. So this is all of the resources that linkerd needs, the control plane specifically needs to run. So we see cluster roles, cluster role bindings. We've got a service account for some of each of the various components. So it's always worthwhile looking through the YAMLs that are being generated. You'll notice that even though I've typed linkerd install, it hasn't actually installed anything. The way we get linkerd installed into our cluster is we pipe it to kubectl apply -f. And now we see everything, all of the resources being created. And we can now do linkerd. Actually, let's look at all the pods again. We now see that there's a linkerd namespace. We see a bunch of pods starting in that namespace. There's also the linkerd check command without the pre. And what this does is runs the same checks, but it's expecting linkerd to be installed. It's expecting some of the pods to be started. And so you can see that it's waiting for the controller to start. The controller is what's used by some of the other components for viewing metrics. It's like linkerd's API server, kind of. It behaves like the API server. So this is starting up. Let's go to this other tab over here while that's running. We'll look at our pods again. Everything's initializing. Again, this is running locally, so it might be starting a little slowly. There we go. Okay, great. So this is good. While that's starting, I am going to create, we want to show you this running, actually injecting proxies into a real application. And so one of the things that you'll notice here is that the linkerd pods themselves have 2 containers running in them. And that's because linkerd itself is running linkerd, and that gives us some awesome metrics. The first thing I can do is linkerd dashboard. And when we do that, we'll see my browser opens up, and linkerd has this great dashboard for viewing information about your application. And you can see the only pods that are meshed are those that are in the linkerd namespace. And we can go here, and we can see there's a topographical map, and this will continue to grow as the proxies detect the communication between each of the services. We call these edges. And so we see each of the components in the control plane. We've got the success rates, requests per second, and everything is looking good. Another quick note here is that the linkerd comes with its own Grafana dashboards. So here we go. We can see the performance of the linkerd identity component. And this one I picked specifically because it is responsible for getting the issuing the certificates to each of the proxies. So to put that into practice, let's go install an application. So we have one that was developed as a sample application by our company, Buoyant. The application is, so we'll do kubectl apply -f. And it's in my projects, Buoyant, Emojivoto. Okay, so what did I do wrong here? Oh, KA is my alias for apply. So if I do kapply, basically I just did kubectl apply. Okay, so we should be in the, oh no, we created an Emojivoto namespace, which is great. So let's change over to Emojivoto. Oops, I spelled that incorrectly. Emojivoto, that's more Italian. Okay, And here we see, great, so the application's already up and running. I can, take a look at the application. We'll port forward by looking at the services. Port forward, service, web service, and we'll do 7,080. Actually, I think I can just do 80. Nope, I got something listening there. I knew I did. Okay, so now I can go to port 7,000 in my browser, and we'll see this application running. It's a fun application. It's written in gRPC, and you just get to vote for your favorite emoji, and then there's a leaderboard. You'll see here that some of these already have votes. And that's because this application has a traffic generator. So if we look at the deployments, we can see there's this vote bot. Bot is sending traffic to web. How do we know that? I know it because the application knows it or is written that way. But let's do something fun with linkerd. We are going to, so linkerd does automatic proxy injection, as I mentioned before, and it accomplishes that by using annotations. So you can annotate resources individually, like deployments or stateful sets, stateful sets, deployments, jobs, any workload you can annotate. I think we're doing all of them now. Or you can annotate the namespace, which is what I want to do right now. So my namespace is emoji vote. Actually, let's first do kubectl-git namespace emoji photo. And we can see that the only annotation there is this last applied configuration. So now we're going to annotate emoji photo, linkerd.io inject, go back over to dashboard, because this is all going to happen very quickly. So let's make sure this is running. Yeah, okay. Let's go to namespaces, and we see emoji photos there, 0 of 4. So I'm going to do the cube control rollout, restart, deploy, -n emoji photo. Okay, and so let's watch those pods as they start up. But more interestingly, in the dashboard, almost immediately, we're seeing that pods are being added to the linkerd mesh, service mesh, and as they come up, we'll start to see metrics. So 1 of 1, 1 of 1, 1 of 1. Great. That's exactly what we expect to see. All of the other pods are shutting down, and because this vote bot is sending these requests for me, now I get to see the service graph of how the services are communicating with each other. So VoteBot generates traffic that goes to web, which then is making calls to voting and emoji. And we see these performance here. You might guess that there are errors because we built them in order to demonstrate some of the capabilities of linkerd. Now I see that we're coming up on time, so I'm not going to dive too deeply into that. My goal was to show you how quickly you can get up and running with linkerd. Oh, okay. Yeah, let's do, so the dashboard is great. Thank you, Patrick, by the way. The dashboard has a bunch of rich information. There's also the linkerd CLI will give you the exact same information. So let's do linkerd stat-n emoji photo. And oops, what did I do wrong here? I think it's pods. Shoot. Okay. Maybe it's stats. Somehow messed this up, and I'm still learning Tmux, so whenever I scroll down, it messes things up. So let's try. Yeah. I don't know. Do you have that problem as well? Control bracket equal. Got it. Thank you. Well, let's do a command that I do know. How about that? Okay, so we do linkerd edges. What's that? So linkerd edges will show me all of the edges in the deployment. And so, as I mentioned before, an edge is a connection between each of these services. So we know that VoteBot is talking to web, multiple instances of VoteBot talking to web, web talks to emoji, web talks to voting. A really fun one, the one that I like the most, I think, is linkerd tap. And tap is like TCP dub for your services. So because linkerd is handling all this traffic that's coming in, we can tap the pods. And what we'll see is just all this traffic that's coming through. All the communication that's being sent between all of these pods is being written here. So this is really good from a high level debugging perspective. But if we want to dig into specifically traffic to a single pod, we can do the same command, but instead we'll just tap one specific pod. And so as we look at the source and destination IP addresses, we see that those are remaining constant. And if I do PO-O wide, I can see that 10.244.18 is the emoji service. So that's all the traffic going to the emoji service. And 10.244.0.19 is the web service. So the source is the web service and it's going to the emoji service. And we can see each of the calls that are being made. So this is really powerful. And we can see this in the dashboard as well. For SREs and folks who are practicing DevOps, I find them using the CLI much more to pull this information into their monitoring tools. Yeah, so let's see, I want to go to emoji. And we can, again, we can see the live calls. There is over here, there it is, tap. So this is our tap inspector, and this is going to show me the same information that I was getting before. And it, again, it's live traffic, it's coming in, shows us the valid requests or the requests that are coming in, the status, the latency. So again, there's the dashboard, which is meant for visualization, easy to read. And that's not to say that the CLI is not easy to read, but this is something you may want to use to tie into your automation, your CI/CD systems, or your monitoring tools more likely. Speaking of monitoring, you may have noticed that there's a Prometheus instance here. Linkerd ships with a small instance and in-memory only instance of Prometheus, which stores 6 hours of data. And I've got another podcast where I talk about, or another stream where I talk about federating Prometheus metrics into a larger scale Prometheus store. So I'm happy to share that with you all as well so that you can see what it's like to go from basic installation up to a bigger, like production grade Kubernetes service mesh, fully monitored application. So with that, I think I get really excited talking about this, showing you all this stuff. So I think I could talk about it all day, but I also think it's time to switch back over to the slides, open up for questions for sure. Before we get into questions, I'm just going to talk about Service Mesh Interface briefly. Service Mesh Interface is a project that was announced almost a year ago at KubeCon in Barcelona. And it is a specification for defining the metrics, the telemetry, the traffic management resources that a service mesh should provide. And so Linkerd, the Linkerd team, the HashiCorp team, Aspen Mesh, Microsoft, Solo.io, And I know there are a couple of other companies that I'm missing, and I apologize, but these are all you might consider a consortium of people who've been working on service meshes for as long as they've been around, and are building out a specification that will make interoperability better and will allow you to build tools on top of it. And I think it was just last week or maybe 3 weeks ago. I've lost track of time clearly. About about 3 weeks ago, I think it was donated as a CNCF sandbox project. So there are now more people working on service mesh interface. I think it's going to be really powerful. It's going to shape the way that service meshes are being used in the future. So I'll share with you a link to that as well, but it's really cool. Oh yeah, so this is what I was talking about before. It defines policy, telemetry, and management. Those are the first three features that they said, these are the features that a service mesh should provide, and this is how they should be provided. So that's, as you would expect, what a specification does. And then just a graphical explanation of how you might expect it to work. So each of the service meshes conforms to the service mesh interface specification so that your apps, tooling, and ecosystem can pull from them in a standardized way. So it's really cool. We'll be doing a lot more talking about it in the future, along with some of the other service mesh providers like Aspen Mesh and Console. So keep an eye out for those if you're wanting to learn more about service mesh. So with that, I want to invite you to come check out, well, here's the important metrics about linkerd. It's been in production for 36 months. We've got a very active Slack channel where I'm at Charles there. You can come chat with me, ask your questions there. That's slack.linkerd.io. We have a lot of contributors, but we would always like more. So yeah, if you're curious, if you want to help build stuff, or you want to meet some really fun people, please join us there. There are other fun people other places, don't get me wrong, but we're with the most fun. So yeah, with that, I'll leave you with this, and let's get to some questions if there are any.
Okay. I'm just posting the link to the call.
Yeah, no worries.
So did you have to write the little vote demo application that you write? Did you have to write something specific in order to communicate with linkerd? So
nope.
It's all
not
automatic,
at all. So,
right?
yeah, let's, in fact, I can show you that repository, github.com, buoyant emoji photo. And so the reason, we actually have two demonstration applications. One is called Books app, and that's a regular Ruby on Rails REST type application. Emoji Photo we wrote for linkerd 2 to demonstrate its gRPC load balancing capabilities. So all of these services are written using gRPC, and so you can see here we've got the proto files that are defined for each one. So it's pretty. But yeah, so to answer the question, if we go and look at one of the services, so the voting service is the one that when you click on the button, then it adds one vote to whatever the leaderboard is. And so if we look at the implementation here, there's nothing here that is linkerd specific. This is all just a pure application, and you can layer linkerd on top of it. So that is one of the goals for linkerd, is to be transparent. The one caveat to that is if you decide to use distributed tracing, you have to instrument your services in order to get the spans from the services themselves. But linkerd is, the proxy will emit spans as well. So, but for MTLS, for observability, for load balancing, you don't have to do anything to your code. Your code, in fact, can make regular HTTP calls, and linkerd will encrypt that traffic and send it wherever it needs to go, as long as it's communicating with another linkerd proxy. If you're making a call to an external service or to a service that is not within the service mesh, linkerd won't encrypt it because the other side won't know how to decrypt it.
Okay. Nice.
Yeah.
And you mentioned that it ships with a Prometheus in memory. If I already have a Prometheus running, does it make sense to use it, or would it be possible, or would it make sense?
Yeah, that's a really good question. Really good question, and we've gotten that question enough times that there's an open issue, and there's ongoing work to.
Okay.
In fact, let's pull that up because it's the question that we get frequently. So we initially included that instance of Prometheus so that folks could get up and running, just like you saw me install this. And I mean, it took me like 10 minutes to install it, but if you're not talking and typing, it takes about 1 minute.
Yeah, that's amazing, really.
And that was the simplicity is another one of the design principles for the linkerd team. So we include that in-memory instance of Prometheus. To your point, we've gotten the question enough times about, can I use my own? So there are two aspects to that. One is we do exporting metrics. So this is what I mentioned earlier about federating Prometheus instances. So I'll share that link with you. It was a talk that I gave for rejects last week. So basically you have your production Prometheus, and it's going to scrape data from this linkerd Prometheus. But let's see if we can find Prometheus visual. So somewhere in here is, and I should know these off the top of my head, but there is work being done to so that you can. We call it bring your own Prometheus.
Mm-hmm.
Yeah. Any other questions?
You mentioned the service mesh interface.
Yeah.
Does it mean that we'll be able to swap like linkerd for another solution and vice versa easily? Is that the objective, or?
The objective is really, so my fun answer is, why would you ever want to do that?
Yeah.
But the goal is to provide a standard. The more conversations that I have with folks who work on service meshes, the more we're all realizing that service mesh is it's not winner take all, right? So in Kubernetes versus Docker versus Mesos, only Kubernetes came out, and very few people are using, even though some people are still using Mesos and Docker Swarm, not as many are as are using Kubernetes. When I speak with people at HashiCorp or HashiCorp or OpenShift, Aspen Mesh, Solo, we believe that it's a multi-mesh world. So in fact, I had a conversation with somebody who works on OpenShift, and because they're running a multi-tenant environment, they want to give their customers the option. So it's multi-tenant Kubernetes environment. They want to give their customers the option of which mesh to use. So if somebody wants to use Console Connect, they can do that. If somebody wants to use linkerd, they can do that, all within the same cluster. Nice. So that's what, that's what SMI is going to enable. And again, I'm excited to see what kind of tooling is going to come out of it.
Yeah, that sounds exciting.
Yeah.
Let me see. Still no question. Yeah. Someone says he's looking forward to seeing a demo of Jagger with OpenTelemetry, but I don't think that's related.
We actually, so I'd be happy to do that again. In fact, when I do a Twitch stream, I'm planning to do a cert manager integration, but maybe I'll do the Jaeger one because we do have an integration for that. So yeah, I'd be happy to do that, and I'll share with you. I should put my Twitch ID on there as well. But if you're following me on Twitter, you'll be able to see when I go live on streams, and I try to announce it a couple days before. But yeah, I'll put that. I'll prioritize that one. And good. I'm glad somebody wants to see distributed tracing.
It's the big thing lately. Jagger and stuff.
Yeah, it really is. It really is. In fact, I just had a call with a user a couple of days ago who's they've got a really interesting setup, and so yep, getting that distributed tracing is people love it.
Yeah. Okay. Well, thanks, Charles. Is there anything else you would like to tell us? Is Buoyant is it the main company behind linkerd?
Yeah, so that's a really good question. I'm glad you asked it. So Buoyant is the company that I work for. It's the main sponsor for linkerd, but linkerd is the only service mesh in the CNCF. Linkerd is wholly donated to the CNCF. One of the things that uh, I wear two hats. There's my Buoyant hat and
Yeah.
there's my linkerd community hat. And so as a community, we're very happy to be under the governance of CNCF. Because it means they have to do all the hard work. No, I'm just kidding. What it means though is
Do
that
you
we
get
have an open.
contributors like do you get more contributors? I heard that, for example, Harbor they got a lot more attention and contributors when they got accepted into CNCF. Is that the
Yeah,
case for you too?
yeah, for sure, totally true. I think, and that's just a function of having more exposure.
Yeah.
You get people that are navigating around the CNCF, people who are looking for open source solutions to piece together for their application. And so, but yeah, that certainly, I don't mean to dismiss CNCF and their power, but for us, the importance is having an honest, open, fun, trustworthy, smart community, people who love working on open source and who, they're people who just like to ask questions and are curious. And if they see a need that linkerd doesn't fulfill, but they love linkerd, then we will work together. But we're always looking to collaborate with folks. Again, it's open source, right? So, yeah.
Okay.
I have a question for you, though, Patrick.
Yeah. Tell me.
How are you staying sane these days? What are you what are you working on? What keeps a smile on your face?
Well, I'm having two cool people on the show, so that helps.
All right, good.
And yeah,
Good.
I have a few side project, open source project I'm trying to finish.
Okay. Well, if yeah,
But yeah,
share those with
l-
me,
l-
and
yeah. Luckily, I'm in a house in the garden because in Paris it would be horrible right now.
I believe that.
I used to live in a very small apartment, so I feel lucky.
Yeah, that's great.
Are you in a house or are you in an apartment in SF?
We're in an apartment, yeah, but
Okay.
it's a building that has very few units.
Okay.
So, yeah,
Because in
but
Paris, buildings are very old and there's no very bad ventilation, and it's not a very good experience to live there.
yeah, yeah, I believe that. I've visited a few times.
I mean, it's pretty from the outside, but not
Yeah,
on
yeah,
the inside.
yeah, yeah. Well, and as a tourist, I get to stay in the places that are fun, right?
Yeah,
Not
yeah,
necessarily somewhere out in the outskirts, but or the different was it the arrondissement.
yeah.
Yeah.
So,
So
where do you learn French?
I have a friend about 10 years ago who was from Antibes, or she is from Antibes.
Okay.
And so she just encouraged me to learn French. And then I traveled quite a bit, and I spent a good amount of time motorbiking through France.
Oh,
And
nice.
so it helps when you're in a little town like Lourdes. Do you know Lourdes?
Yeah,
It's on the Pyrenees Mountains.
where the religious.
Just yeah, exactly.
Okay.
And so
Did you
yeah,
get
it
some
helps when
water? How do you call it?
holy water.
Holy water.
Yeah, I didn't. I should have. But it's nice to travel through rural small towns in France
Oh yeah,
and
it's very
just
nice.
yeah. But they don't speak much English there, so it helps to be able to speak some French.
Yeah.
Yeah.
Okay, well, looks like
Yeah.
people enjoy your demo in the comments. So.
Good. Good.
And
I don't even. Yeah.
okay, well, I'll be happy to do another stream with you whenever you want to. Just don't
Okay.
hesitate to ping me by email or Twitter.
Yeah. I will do that for sure. I think maybe we can do the distributed tracing one that somebody requested. I think that'd be great.
Oh yeah, just let me know. And I have a lot of free time these days, so.
Okay. Sounds good.
Okay.
Sounds good. Well, yeah. Let's we'll chat about it and
Cool.
find a way to collaborate on it. Maybe I'll make you press some keys this time. You can you can do the installation.
Okay.
Yeah.
Okay.
Okay. Well,
Thanks,
thank you
Charles.
very much.
Thank you.
Yeah.
Thank you
Sorry I
for
ran over for so long, but
No, that's
I'm glad.
fine. That's
I
why we're
hope
here.
I hope everybody was entertained on Friday evening.
Okay. Thanks, Charles,
Okay.
and take care.
Yeah, merci. Bonne soirée.
Merci, toi aussi. Bonne soirée.
Ciao.
Ciao, ciao.